The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
An example of Le Chatelier's principle, concentration change in equilibrium mixture. A. Through Le Chatelier's principle, predict how various disturbances listed will shift the equilibrium mixture in the reaction. Okay, great. The addition here of aqueous iron trichloride will increase the reactants, right? And if we have an increase in reactant, then the reaction will shift to the right and we'll have product formation. Now, with the addition of potassium thiocyanate, again, we're going to have more reactant, right? And with the addition of reactant, the reaction will shift to the right. Wonderful. And that's exactly what it said here, right? It said with the addition of a reactant, equilibrium shift to products is favorable. Wonderful. Now, if we take a look here at B, through Le Chatelier's principle, predict how the disturbances listed will impact the carbon dioxide concentration at equilibrium. At a reaction here of carbon monoxide plus H2O gas in equilibrium with carbon dioxide plus hydrogen gas, I think there should have been a plus sign here. Okay. First, we're taking a look at the removal of carbon monoxide. If we remove this, right, then carbon dioxide will decrease and the reaction will proceed to the left. With the addition of hydrogen, of H2O, with H2O gas, if we add H2O gas, then what's going to end up happening, that will increase carbon dioxide concentrations because the reaction will be shifting to the right. With the addition of hydrogen, if we add hydrogen here, the reaction will shift to the left and that will decrease the carbon dioxide. Then we can say here that this will decrease carbon dioxide since the reaction will be going to the left. Perfect. Now let's take a look here at another way we can say what we've just been saying is if we take a look at our reaction quotient when it's equal to the equilibrium constant. Let's just say our products, or there's a decrease in the numerator. If there's a decrease in the numerator, right, then the reaction quotient will be smaller than the equilibrium constant. Thus, we will see an equilibrium shift to the right. Now, if there is a decrease in our reactants, right? There's a decrease in our reactant. We'll just say a decrease here. If there's a decrease here in our reactants, then what ends up occurring is our reaction quotient will be greater than our equilibrium constant, right? Therefore, the reaction will shift to the left. Because now we're going to have more products, and if we have more products, then we have a higher reaction quotient. If we have a higher reaction quotient, then we need to create more reactants, right, in order to balance out the increase in products that we will have. This here is another way of saying what we were just saying over here. I hope that makes sense. Great. So now what we can do is we can move on to our next slide, and now let's take a look at Le Chatelier's principle and pressure changes in an equilibrium mixture.